So when we think about angle of elevation, think of when you're looking straight ahead. So this dotted line is you looking straight ahead. If you were to look up, so your eyes go up to the sky, you're elevating your eyes, so that's called an angle of elevation. So whenever it tells you that you have an angle of elevation of, let's say, 20 degrees, it means you're going to take the horizontal, so you looking straight ahead, and it's saying you're looking, instead of straight ahead, 20 degrees up. So it's creating a 20-degree up from a horizontal line. Usually what that allows us to do is we have an angle, so we can make a right triangle with our horizontal that we can then use either Pythagorean theorem, trigonometry, or special right triangles on. Angle of depression, same idea, except it's when you look down. So if you look down for a certain degree, that's called a depression. So again, it's telling us that from the horizontal downward, it's giving us an angle measurement. Okay, so in our word problems, this terminology could come up, and we just have to know how to use it to determine where our angle goes and what our angle is. So the first one we have here is talking about a kicker on a football field. And it's saying that the angle of elevation, so what does that right away tell us in our picture? That we're going to have a horizontal line measured up. So I know I'm going to be given an angle of elevation here. Let me move that up so you guys can see. So the angle of elevation from the kicker's foot on the football field to the top of the goal bars, so these are the top of our goal bars, is 17 degrees. So that angle from horizontal to the terminal side is 17 degrees. If he is standing, so this is our footballer's foot, if he is standing 131 feet from the goalpost, so here's our goalpost, it wants to know how tall the post is. Okay, so again, we have goalpost, kicker, angle of elevation, so this is the ground, angle of elevation, how high is the goalpost. We're assuming that the people who installed it did it correctly and put it straight up, and it's 131 feet from the base of the goalpost. Once you have it drawn, it turns it into just one of the triangles you've done before. So looking at this, do we know two sides and need to find the third? No, so we can't use Pythagorean theorem. Do we have a special triangle?
No.
No, so what do we have to do? Trig. So I go circle my angle, go across, that's opposite. Across from 90 is my hypotenuse, and then the other side is my adjacent. So which trig function are we going to use here? Tangent. So I have tangent of my angle will equal the opposite side divided by the adjacent side. Put the tangent over 1 and cross multiply. 1 times x is x. And we have 131 times tangent of 17. And you end up getting, I heard someone say it, 40.1 feet. Okay, questions on that one, whether it be how we drew it or how we solved it. Okay, the next one's for the surfers in the class. Any surfers in here? Really?
Yeah.
Oh, okay. This is for you. Huh? All right, so this one is talking about a surfer who's riding a 7-foot wave. Have you ever ridden any that big?
No.
Okay, so here, our surfer, we're going to put our surfer up here at the top of the wave. And we know that that wave is 7 feet tall. So the angle of depression from the surfer to the shoreline. So here's my shoreline. The angle of depression, so instead of, if the surfer was looking straight, the angle of depression would be 10 degrees. So from that horizontal sight line, go down 10 degrees. That's your angle of depression. And it wants to know how far off the shoreline is the surfer. So again, when we measure the height of 7 feet, that's assumed to be perpendicular. So here's a question for you. 10 degrees is not in our triangle. How do we get an angle inside of our triangle? You could do that.
Maybe 80 degrees.
Where would the 80 go?
And
Okay, there's two ways you can think of this. So we know that this is measured as a horizontal, so this whole angle is also perpendicular. So if this is 10, then this is 80. The other way you can think of it is horizontal lines are all parallel, right? So you also have alternate interior angles where that one would be 10 also. Doesn't matter which way you think of it. They're the same and they're going to get you the same result. Okay, so whichever one makes sense to you, whether you use the complementary and make these add up to 90, or you use alternate interior and put the 10 down there. Okay, so once you have it, again, it doesn't matter which angle you use. So does anyone have a passionate response to what angle we use?
10.
10? Okay.
Smaller one.
You want to know something? It makes no difference.
Oh,
Trig is interesting that way. Everything bounces back and forth between the same numbers, so the size of the number doesn't really matter. Okay.
It's like they could do smaller. Right?
Gotcha.
Anything else?
Okay, so we have our opposite of 10, we have our hypotenuse, and we have our adjacent. So what trig function are we going to use?
TOA.
TOA, tangent. Tangent of 10 degrees is equal to opposite over adjacent. Put the tangent over 1 and cross multiply. So 1 times 7, and tangent 10 of times x, we get x tangent 10. So in order to get x by itself, we have to divide both sides by tangent of 10 degrees. And this is where we now type it into our calculator. 7 divided by tangent of 10. 39.7 feet. Okay, so questions on that one, because that was an angle of depression one.
Just like how you set it up, like why is the thing outside of it?
Okay, so the reason it's outside of it, so it's all in reference to a horizontal line. So our surfer here, instead of looking straight up or straight in front of them, they're looking down 10 degrees.
So is that dotted line
That's
the
like,
shoreline, or
no, the dotted line would be like if you were looking straight.
okay.
And so
It would
instead
make
of
more
looking
sense if you
straight,
could kind of-
because we're 7 feet in the air, when we look to see the shoreline, we have to put our eyes down a little bit. And so we put them down 10 degrees
So the shoreline is
over here. I didn't label
oh,
it.
okay.
And would have made more sense if you put the triangle going that way.
It still wouldn't have changed, it still would have been outside.
Yeah. I drew it that way. It's
Yeah. And that's where angle of depression problems, this typically happens where you end up having to use either complementary or alternate interior with angle of depression problems. Okay, I did want to do 2 more because these next 2 have, again, different things to them. So whether you write down the whole problem or just the pertinent information, that's up to you. This next one is about Disney's Guardians of the Galaxy ride. Anyone been on it? Anyone like it? Hated it.
Did they change it?
I didn't. It's the old Tower of Terror.
Why'd they change it?
I don't know.
Because it's probably too scary for little kids, huh?
But the ride itself didn't change. Like, it's just decorated differently. I am not a fan of those rides, but I was forced to go on it and hated every moment.
I still draw.
I really like the Cars ride, one of the Cars rides.
Yeah, I know. There's like
The
a
one where
roller
you race
coaster.
the other car. Yeah, that one I thought was fun.
Yeah, just one of those.
From like on the right after that's it.
Huh? Okay. So here we're talking about Disney's Guardians of the Galaxy ride. It's 199 feet tall. Okay, so here I'm going to draw my Guardians of the Galaxy ride. It's one big tower. It's 199 feet tall. If Josh is standing 132 feet, yeah, you Josh. If Josh is standing 132 feet from the base, so let's go 132 feet this way, there's Josh, waiting in line. And again, we're making the assumption the ride was built straight up and down. What is the angle of elevation from the point where Josh is standing to the top of the tower? So what is the angle of elevation from Josh to the top of the tower? So in other words, how high from the horizontal, how many degrees do we have to go to get to the top of the tower? This is the angle it wants us to find. Okay, any question on the setup? Because that's where sometimes the questions usually lie, is in how we draw the picture.
It's fun tangent.
Okay, so circle our angle. We have our opposite and adjacent. So this is again a tangent. So we'll have tangent of our angle is equal to 199 divided by 132. How do we move the tangent to the other side to get theta by itself?
To divide it by tangent.
We can't divide by tangent. The inverse, what we just did. So theta would equal inverse tangent of 199 over 132. So when we inverse tangent 199 divided by 132, what'd you get? Anyone get a different answer?
Yeah, like that.
Tell me what answers you're getting.
I'm gonna just do it myself.
I got 56.4. Anyone else get that?
56.4.
So check yours again, Dima. So that means it's a 56.4 degree angle of elevation.
I
Okay, questions on that one?
That's 54.4. Or 56.4.
Okay, our last one is about a pilot in a helicopter. Anyone ever been in a helicopter?
Yeah. I jumped
Really?
into the ocean.
Nice. I want to go in one. I've been on little airplanes to skydive, but I've never been in a helicopter.
You skydive?
So much fun. It's
That's cute.
pretty high.
Really?
Okay. So this one we're talking about a helicopter pilot. So here's our helicopter. Again, I'm not artistic, so I'm just going to write helicopter and do a point. That's my helicopter.
It's so far.
I know, right? Okay, so we have a helicopter, and it spots a landing pad below. So our landing pad is over here. The angle of depression, so if the helicopter was looking straight ahead, whoops, I totally drew that way off. Let's fix that. Okay, so instead of looking straight up, in order to see the landing pad, they had to go an angle of depression of 73 degrees.
Do pilots have to learn this? Pilots know this.
Okay, and the horizontal distance to the landing pad. So if we were to take where the helicopter currently is and draw a line straight down, the distance between this point on the ground of where the helicopter currently is and the landing pad is 1,200 feet. What's the altitude? Altitude is another word for height of the helicopter. So again, with angle of depression, we don't always get our angle inside of our triangle. So where can we either put the 73 or come up with a new number?
Alternate interior, or you could do 90 minus 72.
Okay, so we could do alternate interior. So if this is 73, then alternate interior, that one down there is 73. If you would rather use complementary, you could do 90 minus 73 to get the top angle. I usually do alternate interior because it doesn't involve any extra math. It just involves you rewriting it in the correct spot. So, circle our angle. We have opposite and we have adjacent. So again, we have a tangent equals x over 1,200. Put the tangent over 1 and cross multiply. And we get 1,200 times the tangent of 73. And what do you get? 3,925 feet off the ground.